So I want you to imagine we have a very simple economy, and in this economy, there's only two goods: wheat and computers. And the only thing you need to create wheat and computers is labor. So you take labor, and you can either make wheat or computers. And in total, in this economy, there's 50,000 labor hours. And then further, assume it takes 10 labor hours to produce wheat and 100 labor hours to produce computers. So the question is, how many wheat and computers can we produce? And what is the trade off when we produce wheat instead of computers? So we can make a little table here. Um, we've got labor hours, and we can devote those labor hours to computers or wheat. And we can just pick some scenarios, right? So, scenario A, let's say we devote all the labor of this whole economy to computers. So, 50,000 hours goes to computers, which leaves zero for wheat. Um, right? But that's not the only option. We could do 40,000 for computers and 10,000 for wheat, and so on. 30,000 to computers, 20,000 to wheat, 20,000 to computers, um, 30,000 to wheat, 10,000 to computers, 40,000 to wheat, and finally, we can devote no labor to computers and all 50,000 to wheat. So, right, these scenarios are just some of the allocations of labor. The question then is, what is the corresponding production level for these scenarios? So we can make a second table. And so what we want to put for each entry is, right, for scenario A, if we devote all our labor to computers, how many computers are we going to produce? Well, we simply take the total labor hours, 50,000, and divide by how many labor's hours it takes to produce one computer, which is 100, then divide, so 500. So that goes here. And of course, we devoted no labor to wheat, which means we produced zero wheat. And so we can do this for every cell in this table. So for computers, we get 400, 300, 200, 100, and 0. And then for wheat, um, this cell here should be 50,000 divided by 10 hours per ton of wheat. So 5,000. And then going back up, we get 4,000, 3,000, 2,000, 1,000. And so now we have corresponding production levels for each of the labor allocations we considered. And then finally, what we can do is we can graph these, put them on a plot. So on the y-axis, we'll put wheat. On the x-axis, we'll put computers. Let's draw some tick marks here. For wheat, we want to go 1,000, 2,000, 3,000, 4,000, 5,000. And for computers, we want the same thing, but hundreds. So 100, 200, 300, 400, 500. And so now we can plot each of these production options we've figured out. So the first one, option A, 500 computers and 0 wheat, is going to correspond to this point on our graph. So we'll label that A. B is going to be 400 computers and 1,000 tons of wheat, which is here. And we can keep going and plot all these points. C, D, E, and F. And so if you connect these points with a line, that's what a straight line would look like. So we just need bigger points. And so what this line is telling you, right, think about what this means. All these points are potential production values of wheat in computers under different labor value scenarios. But we only sampled a few of them, right? There's infinitely many. And so in between E and F here, there's lots of different ways you could allocate labor, right? So what the line is telling you, it's telling you all the different ways you could produce wheat and computers, right? So we didn't explicitly put this value on our table, but 4,500 tons of wheat and 50 computers is an option. And so what this line is, right, we call this the production possibilities frontier. Right. And as we just said, it's um, all combinations of two goods that an economy can produce. So that's it for this lecture. In the next one, we'll dig in a little deeper into the production possibilities frontier.